Okay, this is question 4 from the Level 2 Trigonometry worksheet. It says a boat is observed from a lighthouse that is 55 metres high. So the lighthouse is 55 metres high. And a boat is observed out on the water somewhere. So we'll put the boat out here. I'll put B for boat. At an angle of depression of 11 degrees 42 minutes. Now remember, angles of depression or elevation are measured from the horizontal. So here is a horizontal line. Lighthouse, at the top of the lighthouse, we notice a boat at an angle of depression of 11 degrees 42 minutes. Okay? So the boat's there. Now, 2 minutes later, the boat is observed again at an angle of depression of 25 degrees and 7 minutes. Now, we know that that's bigger than the original angle. I know these are not drawn to scale. So the boat must be now closer. So I'll call this B1 and B2. And that second angle of depression in there is 25 degrees and 7 minutes. And the question is, what distance has the boat travelled in 2 minutes? So we need to work out this distance here. But to do that, we can't use just, this is the right angle as well. We need to look at the two right angle triangles separately. So the first right angle triangle, this is 55. We don't know what this distance is. I'm going to call it Y. Right angle, this is the second point of the boat, B2. Now, if that second angle of depression is 25 degrees 7 minutes, then by alternate angles, this angle down here is also 25 degrees and 7 minutes. So I can work out this distance Y here. I'll call this distance Y along the bottom. So I can go tan of 25 degrees and 7 minutes equals 55 over Y. Because Y is on the denominator, we can swap it diagonally there. Y equals 55 over tan 25 degrees and 7 minutes. And just working that out, get 117.323573. Just not rounding off any decimal places yet. So now the second triangle, the larger triangle, I'll call this B1. We know the height of the lighthouse is 55, and that first angle of depression was 11 degrees 42 minutes. So therefore, by alternate angles, this is also 11 degrees 42 minutes. So I'll just call, well, this is the whole of the right angle triangle. I might actually call this whole distance Z. So I'm going to call that Z. So the tan of 11 degrees 42 minutes equals 55 over Z. So Z equals 55 over tan 11 degrees 42 minutes, which is 55 divided by tan 11 degrees 42 minutes is 265.584954. So therefore the distance that the boat has travelled is the second distance, 265.584954, minus 117.323573, which is 148.26138. This would be in meters. Okay, so the distance that it's travelled in meters is 148 meters to the nearest meter. Now the second part of the question says, what is the speed? What is the speed of the boat to the nearest nautical mile per hour? Now it says that 1 nautical mile is 1.852 kilometres. So we'll need to convert this distance into kilometres. So I'll just use the rounded. I'll use the non-rounded answer. So 148.26138 metres is equal to 0.14826 ... kilometres. So I'm just going to keep that answer in my calculator, divide it by 1,000 to convert it to kilometres. Now, because 1 nautical mile equals 1.852 kilometres, therefore, to convert from kilometres to nautical miles, we need to divide this quantity by 1.852 to get it into nautical miles. So therefore 0.14826 ... kilometres is 0.14826 divided by 1.852. I'm just going to write NM for nautical miles. So dividing our answer by 1.852, and I get 0.08000547 ... nautical miles. Now, that's the distance in nautical miles. The question is, what's the speed? Now, we know that speed equals distance over time. Now, the distance is and we want the speed in nautical miles per hour, so it's 0.0800547 nautical miles divided by, it says that it takes 2 minutes for the boat to travel. Now, 2 minutes, to convert that to hours, we divide by 60. So I'm just going to write it's 2 divided by 60 hours. So we need to keep that answer in our calculator and divide by, open bracket, 2 divided by 60, close bracket, and we get 2.40 nautical miles per hour. And they want it to the nearest nautical mile per hour, so it would be 2 nautical miles per hour. Okay? Okay, this is level 2 trigonometry question 6. A, B and C are 3 towns. The bearing of B and C from A. So we want to be starting from A, putting a north sign there. So the bearing of B and C from A are 295 degrees and 205 degrees respectively. So there's A. The bearing of B is 295. So here's my north sign. So I've got 90, 180, 270 and a bit more. 295 would roughly be like this. Okay, that one's 295. And the bearing, so that's B up here, and the distance there is 280 kilometres. And the bearing of C from A is 205. So I've got 90, 180, 205 would be down here somewhere. And this is a longer distance of approximately 800 kilometres. So this is C down here. Now, if this bearing, so if one bearing is 205 and the other bearing all the way is 295, then the angle in between is 295 minus 205, which is 90 degrees. In other words, I've got a right angle in between. I will do that again. The first bearing is 295. The second bearing is 205. They're both starting from north, so the angle, this angle in between must be a right angle. Okay? So I'm going to join them up. So the question is to find the bearing of C from B to the nearest minute. First bearing, 295 all the way round. Second bearing, 205. The difference between 295 and 205 is 90. That's a right angle in between. Question is to find the bearing of C from B. So from B, I put a north sign at B and I go clockwise until I find the direction that C's on. Now, girls, this is a bit tricky. It's quite tricky. All right. So to find the bearing of C from B, we start from B, put a new north sign and go clockwise. So I want this entire angle there. Now we know that this first bearing of B was 295. So if that red bit's 295, then this remaining bit up there is 360 minus 295, which is 65 degrees. So if I want this bearing here, I'm going to break it up into 2 parts. Just going to move that 280 down here. So I've got this red part. I want to work out this red part of my bearing up there, just up there. This bearing is made up of 2 parts. This pink part here would be co-interior with this angle down here, which is 65. So to do that, we do 180 minus 65 is 115 degrees. So this angle up here is 115. That's one part of my bearing. But now I need this other angle in here that I've shaded blue, and I'm going to call it theta, that other angle in there. So now I take my right angle triangle, that's a right angle, that's the hypotenuse. I must have to use opposite over adjacent. So tan theta is opposite over adjacent. Tan theta is 800 over 280, which obviously simplifies. So therefore, has anyone worked out what theta is? Anyone? Sorry?
70
Okay, 70 degrees, 43 minutes to the nearest minute. And so therefore the bearing of C from B is what? How do I do it? I want that whole angle. What do? I do what, girls? I want this whole angle. 115 degrees plus 70 degrees, 43 minutes, which is no, it's not. It's 185 degrees. Is that right? 185 degrees, 43 minutes. That's question 6. A bushwalking party leave point P and walk on a bearing of 335. So there's P. Put a north sign. 335 degrees is 90, 180, 270, 335, somewhere up there. They walk for 11.4 kilometres until they reach Q. From Q, they walk on a bearing of 65 degrees. So put a new north sign, and you need to go 65 degrees there. But they walk further this time, so 18.7 kilometres. And this angle in here is 65 until they reach R. So that's your diagram. So that first angle here was 335. That first angle there, around there, was 335. And the question is, what is the distance from P to R? We've got this 11.4 there, and we've got this 18.7. We need to work out this angle that I'm pointing to here and this one here. How can you work out this angle here? Girls, I know that's 335. Can you tell me what this little angle up here would be? The remaining angle in that revolution? That would be 25, great. So that little remaining angle in there is 25. So girls, whenever you've got bearings and you've got two north signs, we want to be trying alternate angles or co-interior angles. Co-interior would only work if I knew this bit that I'm referring to now. But what about alternate? If that's 25 just in there, what's this bit? Girls, look, Z. What's this angle that I'm pointing to now? Anyone? It's 25 by alternate angles. Now, I've got a north-south line. If that's 65 and 25, what's the angle in between? It's a right angle. It's 90. So I've got 335 all the way up to there. For a revolution, which is 360, this remaining angle in here is 25. I definitely need to work out an angle in the triangle to be able to use trigonometry. And because you've only learnt right angle trigonometry, we're hoping that angle in there is going to be 90. So we say this is 25. Let's go alternate angles. This must be 25 down here. I've definitely got a straight line here. And 180 minus 65 minus 25 is 90 degrees. So this angle here is a right angle. And now, girls, if I can draw the right angle triangle separately down here if I want. I've got a right angle, I've got 18.7, and I've got 11.4. And now you can use trigonometry in that triangle to find any angle. So to find the distance, how would we find the distance? Pythag for distance. Distance between P and R. I would use Pythag. And the second part, the bearing of R from P, you need, girls, it's a bit tricky, but the bearing of R from P, you need this tiny little angle just in there. Distance between P and R, so PR squared is 18.7 squared plus 11.4 squared. PR squared, did anyone work out what that is? Sorry? 479.65, therefore PR is the square root of 479.65, which is? Sorry? So what was it actually? 21 point what? 9009, etc. But to three significant figures, I only want three figures. 21.9 is three significant figures. And that's in kilometres. Now, the next bit is tricky. Having a closer look, please, at the bearing of R from P. Here's P, I put a north sign and I go clockwise. I need this little angle here. Now, I know that this bit over here is 25. So if I just find that whole angle here, I can take, so if I just find this whole angle down here, the whole thing, but I know that this part is 25, then I can subtract 25 from what I find to work out this little bit here. So here I'm going to need to use sine, cos, or tan. These are tricky, girls. Tan theta is 18.7 over 11.4. Has anyone worked out what theta is? Tan theta is 18.7 over 11.4. Anyone? What? 58 degrees 38 minutes. Therefore, the bearing of R from P will be 58 degrees 38 minutes minus the 25, which is 20, what's that, minus 25? 33 degrees 13 minutes. No? 33 degrees 38 minutes. Now, we have to find this angle here in that triangle because we want the bearing of R from P, but the problem is there is a north sign that goes right up inside this angle. We know on the left-hand side of the north sign that's 25 degrees. So the right-hand side will be whatever the whole thing is, which is 58 degrees 38 minutes. So the whole thing is 58, 38. Take away 25 gives me that little bit in there. Girls, these are quite tricky.